Today we will be doing some fixes and probably conditions, I guess. I don't know if we can get to the condition stuff. But I was thinking offline, like I added some stuff here. This is still a priority, the conditions. Oh, actually, this one, the arrays, I don't think I'm going to implement them for now. But then I was trying to have this working. So the stuff that I tried to do a few videos back, um, to have like the print stack working, but I could not have it like working for any reason at all. Like I didn't understand why this was not working. But I think this is caused um, because we are using call saved registers instead of caller saved registers. I'm not really 100% sure about that. Like I really not. Oh fuck. Yeah, I hadn't compiled this with this code yet, so let me do that. So let's go back. So if I push, I don't know, 420 onto the stack and then I do .s, it's going to say fault. And this happens even if, like, it has nothing to do with this macro, because even if I do a simple printf with nothing else, so as long as I call some C function in here, this is going to blow up. Yeah, this blows up. And I think this is because of the call is saved registers instead of the caller saved registers. So we should try to fix it, right? We should try to fix it. And I was looking at the ABIs, and I think this is a reasonable like register collection. Let's open the Windows x86 64 ABI and the Unix as well. So this one and this one, I guess. All right, man. I just want the registers. So many pages. Why do I need to know? No, just give me. Sure. Okay. So this is the reason. This is preserved across function calls, but we are not restoring because like main itself is a function, right? And we are not restoring whatever we overwrote here. And I think that could be one of the reasons. Um, so we basically need to use this stuff and properly restore them if needed. So these are very rare, so I still use like consider them as being possibilities. Um, and then racks can be our temporary register, right? Because racks is just used for the returns, and that's just always being overwritten, so we can just use that as a temp register. Yeah, and we need to be careful to properly like restore the RSP and properly align it. I think that's important because apparently RSP, because of like the SIMD instructions, needs to be 16-byte aligned. So we need to take that into account. And then here, for the Windows stuff, calling convention, I think it's pretty similar. So, fuck, this is not. Where was it? The registers. Okay, I don't care about that. I just need something to interface with C. I don't, because anything outside of C, I can keep my own convention because I'm not calling anything external. I just need some way to call sim functions following the convention. So Rax is also returned. It's fine. We can use as temp. Then these are volatile by color. Correct. We can use them. These are the ones that we are using and it's fucked. So yeah. And these are also volatile. This is the third and fourth. So it's the same. I guess it's the same. Um, Yeah, and in this case we are going to manipulate RSP because we want to align it, because I'm not really sure, like for example in our for primitive we increment this by 24 and this can misalign. So yeah, let's try to do it. So here let's change this. So what did I say here? R10 R11, let's just confirm. Yeah, R10 R11 R10 R11. Yeah, okay. So R10 can be our T, R11 can be like the address of S, and then rux can be temp. Yeah. So in this case we can replace all of these. I can even say that R12 R12 R12. Yeah, all of that can be. Do I have any other R12? I should have. Yeah. So here, okay, there's a lot of instances of R12. Okay, so this should be now what was it? This is the stack, right? So this should be R11. Okay, we change it for R11. Now we need to change R13 to R10. Okay, let's trust that this does work. So R10, sorry. All right. Then we need to change R14 into rux, like so. Rux. Okay. Do I have any? I don't think I have any other register. I never used more than 3 registers, I believe, because everything else is in memory, right? We just push to memory. Yeah. So that's okay. I think. All right. So now we've handled it. So let's reserve those registers, at least so the compiler is more or less aware that we will use them. Here we can just call it T, and here we can call it S, SP, I guess, or something. And yeah, this is R10, this is R11. I don't know how much this is going to impact the compilation process. Like, we eventually are going to get rid of these inline assemblies, and I want to just emit bytes and the opcodes directly. I don't really care about the assembly, because it's like as I develop this compiler, it's getting more in the way, and it forces us to do stuff that is completely like lunatic. But yeah, like I think I'm just going to do for everything what I did here, and have my own thing, and ignore the GNU assembler. But yeah, so we did that. We reserve them. I don't know if the compiler is going or not going to use them, but okay. Then we can do the following. We need to do this, right? We need to do a macro that allows us to push and pop stuff that we need from the stack, align the stack, call the C code, and then pop it back, right? I think so. But well, oh yeah, because we restored the original RSP. Oh yeah, it's fine. So my comment seems to be reasonable. Okay, we can put it here. So instead of call, we can define that. So we can call it call C. I don't think I need this. Do I need this? I don't think so. Let's just do that. Instead of this being, yeah. Well, we can keep the comments. Well, I can do trim trailing white space. Okay. What are you complaining about? Expected. Oh yeah, because it needs the stuff. Okay, it's fine. So we can call this save t, and t is going to be R10, right? Okay, so we save t, we save s, which is R11, we save RSP. Oh yeah, this is originally put it in a temp. We move, we push the temp. Yeah. Then I still don't understand what this cobbler stuff is. Run any C code. Yeah, we can just say run C codes, right? Then we need to restore the stuff. Okay. And to restore it, we can pop RSP. Then this we can just so this can be the R11. Right. So we restore S, and then we restore T, which is R10. And these we can ignore, right? Like so, basically. And this, and here, let's say something like, yeah, something like this. Oh, that's not what I wanted. And also not this. Okay, this. And I can just add that. It should be okay now. Or maybe it doesn't like, yeah, it's fine, I think. Let me just align this properly. So, fuck. Yeah. So there is one missing somewhere. Yeah, already saw it. It's in here. In here as well. Okay. So yeah, I can even say save S. I know what the fuck S is, so restore, yeah. And then here, this is no longer force, so let's call it S and T. Okay. So that's that. Here let's, yeah, something like this, I assume yes. Let's remove this, and this is how how we are supposed to use it. So let's try it. Anywhere we call C codes, we should do that. So we can do this after initializing stuff. It's okay. Yeah, we can do that. This is not calling C codes. This one is. So let's extract words into here, and then here. Is this going to work? Call C bam bam. I don't think so. Yeah, expected an expression. Fuck. So let's convert this into the following. Do that. Then while words, right? While words like this, and then why what? Too many arguments. What the fuck are you talking about? It's completely delulu, I must say. Yeah, at the end we can just do that stuff. Just come here and do that, and this should work. But now, why? It's strange. Okay. So this is also fuck a function, but this function is nice. Is like it's not the only function. So the only functions. No, this one it should be fine. Oh, but this one calls str talk. Oh, okay, I see. So let's do the following. Instead of doing that, because any function that we define ourselves should be okay. So we can even say static inline, just to be sure. But then let's bring back. Okay, let's do the following. Let's bring back this. So for this word equals next. But inside the functions that we defined, if we call like a libc function, we need actually to wrap this, I think. So that can be wrapped, and we need a macro upwards, right? Yeah, we need this macro like super high. Let's define it here. Here we just need to say call C, and this is the C code it needs to be called, so something like this, right? Yeah, so basically this does, yeah, I think it's fine. And then fcat also needs something. So fcat returns a sharp pointer. So sharp pointer, let's say, I don't know, s or something. This declaration needs to be up and there. So we can call this, and we can say that s is equal to this, and here we just say not s, okay. And here we can say the same stuff like this. Yeah, so this should be okay now. So this next now calls any libc function inside this macro, so we should preserve whatever we were doing. Okay, let's just confirm that still works. So let me remove this for now, and let's fuck. Okay, call global register used for global register variable. Huh. Let's use a plank. I don't feel like thinking today. So okay. Yeah, sure. I don't know. Let's use this one, I guess. Shorter message. Oh, it's already, fuck. I had no idea that this was already above. Let's try this one, maybe, without the comments. Oh, so we are already hitting the 16K context limit. Yeah, that is actually fucked. If we do this, are we going to overflow the limits? Yeah. Alright, so let's maybe remove this because this is not really important. Oh, but there is a lot of shit. Fuck. Yeah, so let's maybe remove that, which is also not that needed. Yeah, and it already fits in the context. Okay. Alright, let's see the results. Okay. What are we even talking about? Then this. Oh. Well, but that shouldn't, no. That shouldn't actually be the case. Um, yes, there is a need to wrap them in as so I think, well, maybe it's because I didn't use the correct words. So operand number out of range. Is it pop Q? Is it pop Q? I don't, let's see what I did in for. I no longer remember. No, I use push. Well, I only use push there. I never used pop. Operand number out of range. I don't even know what that means. So let me just do that and see where this gets. Reference and input output operands. Oh, does it? Oh, fuck. Yeah. So this is that and that. Okay, so that was the issue. I see now, I see. It's fine, okay. Okay, so, but now it is still complaining. But let's see if this... Okay. Yeah, it's working, okay? So it's working basically. If I terminate, we have... Okay, so it's fine. But now, what about this one? Why do we have an error? Um, bind the registers to registers that are Kali saved. I had Kali save registers. I'm trying to remove them. So let's not declare globally, I guess, and we just need to make sure that our assembly is properly done, and we actually wrap every single C function call that is not within our compilation unit. We need to mark it, right? So this one is going to change a lot of stuff. I don't know why I didn't fucking know. ESP clovert. I don't even know how to type that. Clovert, right here, correct. R. I still need to understand. No, yeah, of course it's not. So RSP, yeah, that's correct. Okay. So it's basically that. And here it's the same. Well, not really. This is memory because this is not going to change this. Yeah. So that's actually correct now. Yeah. Sure. And then register SP as a fixed purpose. Yes. So let me not do that because the compiler does not like it. Yeah. Okay. So is this going to compile? It does compile. So the compiler is fine with it. And now let's keep going. I guess let's keep going. So this word is fine. Okay. Then this one is static inline. We call is digit. So, and this is part of clib. So I guess we need to actually also wrap it just to make sure, right? We just need to make sure. And this returns an integer if I'm not mistaken. Yeah, integer. You can call it is, I guess. And call C. And here we can just say C equals, actually is equals bam bam. We can even, oh, we don't even need, yeah. we don't actually need. Let me go fix it here. We don't need this because I'm already adding it there. Yeah. Okay, so this function should be okay now. And then 2i64 doesn't need anything because it's like everything is part of this compilation unit. So we don't call any external stuff. Then this one, well, we use memcopy. Okay, so let's mark this as static inline. And let's handle this memcopy, I guess. Yeah. So we don't even need to extract anything. We can just say call cmexo, and that's it. Then this one is one of our functions. Oh, okay, static inline. This one needs to be wrapped. Right? And this one also needs to be wrapped. And I'm just marking everything as static inline just to make sure like the compiler understands this is not going to be called anywhere. This is just part of this compilation unit. So that one, this one is also something, okay, but this is a macro, so it's fine. So since it doesn't call anything, it's okay. Then call is going to call functions that are inside our code segment. So the function that we actually created, so they are not C functions or C leave functions, so it's okay as well. This one we already fixed. strcmp we need to wrap, unfortunately. We need to wrap. So let's do something, I guess. What can we do? Well, we could, let's say something like this. So is eq, right? And then every time we have this, oh fuck, is this, and that, we can just say the following. Call C, well actually you need to begin an expression, then do call C, this, like so, and then we move all the way there, we close it, and we close that. We do that, and we just return C as the end of the expression. But this may not even be able to, yeah. So we can wrap, to simplify stuff, we can wrap strcmp, so we can call it inside these if expressions. Yeah, I think it's simpler. Why I don't know why it keeps complaining about this shit. It doesn't have too many arguments. I don't get it. Yeah, so let's do the following. Here we can say something static inline str eq. We can even like say eq const char a and const char p, and then we can just say return, well actually you need to, yeah, we need to say the following, int I don't know, cmp, I guess, and here strcmp, we receive a and b, and you can do call c of cmp is equal to that, right? And then we just return cmp is equal to 0. And then we can, since we already wrapped it and we do that, we can just replace all of these things by this, and we can even remove that. So yeah, and this is going to return a boolean actually. Okay, And there is something. Oh fuck. So this is p dot word, right? Yeah. And there is also no, nothing else is fucked. Okay. So we handle that is fine. This 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 is not fine. But we can just do call C like so. It should be fine now. Then this is fine. strlen is also not fine. But this one is easy to fix. Just say call C like that. This one is also easy to fix. Call C. We just do that. strq, then another call C. Okay, this one is fixed. This one I think does not. Oh, it has real lock. Okay, so let's mark it as static inline as well. And let's wrap this call C in here. Is this a macro? This is a macro, right? Yeah. But I do not know if this calls a function or not. Yeah, this is a function. So let's also wrap it. By the way, let me just wrap this in here so it's 100% sure that the compiler actually puts all of this token inside. Then here, static inline. Here we already have streq, so we can just replace that by that and with this, and this should be working now. Okay. Where was I? So I was in the vocabulary stuff, so I was up here. So that one is fine, this one is fine now. This one is fine. This is fine. Fine, everything is fine here, fine. Yeah, I think everything is okay now. This one is also fixed. And everything else is fixed. Okay, let's see if this compiles. It does not. So I need to always wrap this in parentheses. Okay. Statement with no effect. Oh yeah, fuck. So this is n equals. Yeah. Is there anything? Is EQ? Oh yeah, this is no longer used. It makes sense. So if I do this, okay. And let's say if we can test it with this behavior here. If I try to define a word inside a word, then we should not have segfault. If I do this, yeah, and we do not have segfault. So that's actually good, because before we were having segfaults because of this printf, but now we wrapped it and it's no longer segfaulting. Let's say error, just be super explicit. And here, yeah, as well. Error. Yeah, and it's fine. Okay. So now if I implement that word, that debug word that I wanted to, this is a debug word, and I say streq, and I just do the following. So let me not print that here. Yeah, let me not print this here. Let me just do that, and let me print this stuff there. And in here I'm just going to do two spaces and then call print stack. So now this should finally work, I think. So if I do 69 420 and I do .s, fuck, .s still did not work. Why? But I mean, it's not segfaulting. That's something. Okay, it's not segfaulting. But why? Oh, why do I only have one element in the stack? What the fuck? It's segfaulted here. Yeah, but in this case it's normal because, well, it's not really normal. Oh fuck, yeah, it's still missing stuff here. So this needs to do call C, bam, like so. So that was also missing. And this also needs to do call C. Call C, like so. Right? And here, I think I also need call C. Yeah. So here, I also need call C. And do that. Then here I don't need it anymore because my registers are already trashed. I don't care about, well, actually I do care about them. So yeah, I still need to do this. Because here I'm going to print them, so yeah, I still need it. I still need it everywhere. Let's do this, that, this, and that. And here we actually don't care because we already have done everything we need. So if I do 69 and then dot .s, it's still fucked. Okay, but at least it did what it had to. What it had to. Yeah, this one is correct. So I don't get it why it's not. So if I do something like that, and then that, and that, and if I do this, and just say words, let's just try it. So if I do 69, it doesn't print any. Is it? Because, no, it should. Oh yeah, because here 69 entered here and it continued. Okay. But then if I say .s, okay, it's not entering, so it's exiting somewhere. So we have here bad, that, that. We have this else. Oh yeah, here, it's entering here. So we need to say call C. There was one extra stuff missing, so error. And I need to place, okay, let me close that. I need to place this stuff in there. So yeah, else if that, and here I can just mark it as a debug word because I don't know if this is going to be in the final programming language. We can implement it then in terms of other words, but for now this is very useful, I'd say. All right, so let's try again. We push 69, we do .s, still doesn't work. Fuck. What if we do a word that does not exist? Like, okay, it's segfaults. So it's still segfaulting. This does not do anything special. Why the fuck are you still segfaulting? So let's try to do this just to be 100% sure. I don't know. A bunch of A's. Well, now it worked. Is it because what the fuck is going on? And if I do 69 and then .s, it stops working. What? That's strange. So that extracts the pointer. God damn. And if I terminate, so there is nothing in code segments, yeah. Well, but 69 didn't get pushed. What? This worked. W69. Yeah, so something is fucked. Oh no, I broke something. Fuck. So if I do, I don't know, this, and I do apply, well, that worked. There is something strange with what? If I do 69, this worked. If I do 69 with a quote, right, and I do apply, that no longer worked. Huh. I think I fucked up some register. Fuck. And I don't even have Git in this repository, so man, I cannot even revert. So let's look at apply. But the weird thing is that when I do this in the same line, it works. But when I do this in separate lines, it stops working. What the fuck? And the code is the same, by the way. Wait. There is something missing here. I'm missing a return, aren't I? Why am I pushing C3 here? So this is the 69. I'm pushing return in the incorrect place. Am I? Wait. So this one is the literal. But wait a minute. Wait a minute. So did I fuck up this? So if I get that, but this should be working. If I do this, 69, that, and I do drop, it's still, yeah, it's still fucked. So there is something fucked with the top of stack. Oh, wait. So is it, no, but that's, I think this is fucked. If I don't do this here, so let's say I don't do this kind of shit here. Well, I can actually remove it. I only push R10, push R11, pop R11, pop R10. So let's say I do that. And I do not touch with RSP. So if I do that, and I do apply, no, it's still fucked. Oh, I fucked it like somehow very early. Fucking hell. I think this is Pro Max Clanker time, to be honest. Because here, this should be okay, because like here we are preserving and here we are popping the preserved stuff. Okay. Because I don't even know exactly. Well, but it's not crashing at least. We can do something like, I don't know. Maybe it's this call. Well, but the thing, like the weird thing is that if I do this 69, bam, and I do apply, it works. So it is something to do with the new line. It is something to do with the new. It can't be this shit, right? If I do that, I can remove that maybe, but it shouldn't really influence it. Because here then we do str talk. Man, I truly do not know. I truly do not know why changing line fucks up everything. So this, like, it even looks like it has never been, and yeah, it fucks up completely everything. Like any other command executed after that is 100% fucked. So if I do all of that in the same line, and then for 20, oh fuck, I forgot to add a space. Now out of a sudden everything is fine. And if I do this, let's try 42 for example, bam, bam. If I define the word and I execute it in the same line, it works. So man, when I change lines, the entire code gets fucked. Oh, that's weird. What it so it needs to be something here, right? If I don't do this shit and I just do fuck. If I don't do that shit and I just do this, are you still going to behave in a very weird way? Yeah, so let's comment all of that. If I do this, are you still fucked? So yeah, it's segfaulted now. But it didn't segfault before. Huh. Let's call the Clanker Pro Max now and see how it goes. Because I do not have enough knowledge about machine code and all of that. Oh wait, yeah, this one is the correct one. Okay. So this is such a weird behavior. Okay, let's revert that. I can copy this. How do I even explain this to the Clanker Pro Max? When I put all my code in a single line, it executes, but after I finish lines, nothing takes effect. If I remove policy from next, I get segfaults. Find bug. Right. So I mean, I don't know. Like this f gets. I mean, to be honest, these strtalks functions and all of these shit, they are implemented and written assembly, right? Nowadays. It says to be super optimal. So it could be one of that stuff. Yeah, this is like all handwritten assembly. This I don't even know. Well, this is actually implemented, okay. But yeah, I'm not really sure. Let's see what the Clanker Pro Max says. Or maybe I just fuck up some... Yeah. Yeah, the Clanker said because strtalk has an internal pointer. It could be that. It could be that. Yeah. Huh, that's also a possibility. So instead of doing call C all the time, I can literally just say, that's actually smart. I can actually just say that. I don't even know if this is going to work 100%, but let's go with it. So if I do this, then I don't need any threads. This one, now it's fine. And this one can be extracted away. And I can do that. If I do this, this should be also be fine because calseek like accepts any block of code, right? Unused variable, yeah, this one. Okay. Now if I do 69 and then 420, I only have 69. Fucking hell. So that's still not. You're into two separate classical low-level programming issues: a state management bug with C standard libs, string tokenize, and calling convention clash between C and your fourth virtual machine. Let me copy all of these stuff so you can read it as well. Okay. So, this is a very good, it doesn't matter, you are running, it doesn't matter. Okay. The multi-line bug, strtalk state corruption. The reason your code executes perfectly on a single line but fails on multiple lines is due to how you are calling strtalk inside your while not result loop in the next. Wait, didn't I fix that? Oh yeah, it's here. Yeah, while not result, okay. When strtalk reaches the end of a string, it returns null and updates its internal state to remember it has finished. To parse a new string, you must pass the new buffer pointer to strtalk. Sure. Because you said is first false before the loop, when fcat reads a new line into tip, you are calling strtalk null. Since strtalk just finished the previous line, passing null causes it to immediately return null again, completely ignoring the new text in tip. It ends up in infinite loop, hitting all your lines until end of file is reached. Once you read new data into tip using fcat, you must pass tip to strtalk to reset. But isn't that what I'm doing? Okay. So is first that fine, is false false. And what am I doing here? Oh, it's tip, right? Oh, fuck. So did I copy paste this line before without knowing? Probably. Probably I copy pasted it. Fuck. So 69 for, well, 69 and 420. I only have 420. Okay. Let's keep going. But at least like 420 executed, right? So if I like 4, like 69, 420, and then I have 24, 96. Okay, so it's only printing the very last thing. Okay. You mentioned if you remove, yeah, but that one compiled using ABI. According to this calling convention, certain registers are call is safe. Yeah, but when you call C standard C library functions, yeah, but that should be Okay, but this one is now fixed. But now I need to understand why. But if I do something like, wait, 69 or 20. Yeah, now only the last word is actually red. So if I do something like, I don't know, print F here, just so I can actually see what the fuck is going on, and I print results. So what are we actually returning here? 69 for 20. Okay, we are returning 69 and 420. So that's not an issue. Let's ask the clanker again. Now, if I have multiple words in any line, it seems that only the last one is executed. And let me give it some examples, I guess. Well, let me see how it misbehaves with functions. So if I have this and I have like I don't know, n is for 20, right? And I do w apply. Okay, it's segfaulted actually. Okay, so there is another issue there. If I do w69, do w, okay, and I do then 420, and I do n. Yeah, it only has this. Okay, so let's copy this. Because I might have fucked some of these things here below. But it doesn't really make much sense, to be honest. So if I push a literal, or maybe it's just a print function that is fucked. I mean, it could be. So here, I don't need anything. Here I could even do something slightly more optimized by doing this. Otherwise you are going to be pushing and popping registers all the time. So I could just do that. And wrap this into a block. Like so. And here I can do this. And actually I could even do this print inside the block itself. Yeah, and this is slightly better. I don't know if that makes a difference. Oh yeah, this one. Is that what you want? Yeah, so warning backlash a new line separated by space. Oh, okay. Green. Okay. This shouldn't like really change anything. Yeah, it's still fucked. So in this refactor, I've really fucked this stuff. Oh, by the way, the clanker is still thinking. And still doing his stuff. While this thinks, let's try something. So if I just do this. See, code that. If I just do that, is it still going to get fucked? Yeah, we got a segfault now. Because we are not using Kali saved registers. Yeah, it makes sense. Oh boy. Like, the longer I work with this, the more I want to just write shit in assembly directly without even using C. Right. Yeah. So it could be that it could be that we need to still do that, because basically what the Clanker is saying is that R10 and R11 can still be used by loops, right? Okay, like I can copy this shit. Let me see. Okay. Okay, let me copy this properly. Where the fuck does it? Okay. So what it's saying is that, sure, while your fourth state is fine, this still does not prevent the loops, like with str eq and everything, and ifs and else and everything, to use these registers as temporary variables. Yeah, exactly. So to point to random, well, it could be that it could be yeah, so we can do that, and here we need to change that so we do not redeclare it. Yeah, we need to say something like underscore R10 and underscore R11, and here we do this. Fine. And then what did it suggest? So it suggested to do this kind of shit. Fine. Sure, and we just protect these registers with call C. That's what we did. Yeah, that's fine. Clean up clobbered list, because you see now statically knows these registers are reserved globally. It will throw a compilation error if you try to explicitly list them in the inline assembly clobber list. You must remove R10 and R11 from clobber list at the bottom of all your... Okay, I didn't know about that. So let's try to find everything from the beginning. So this sheet needs to be removed. And then we need to start removing stuff from here. Maybe that's why it was throwing an warning before. Yeah, let's see. Still needs to be removed. Alright, still. And I don't think we have... Oh yeah, we have assembly here. Okay. We have assembly anywhere else? I don't think so. Okay, so if I compile this, it threw a bunch of errors. Fuck, this is now not how you define it. Maybe it's... yeah, maybe it's missing this. How did I define it before? Oh, with underscore. Okay. Um, I know I already defined it once. I don't know the syntax. Wait, let me put it in the clanker. Why are you not copying? Oh fuck, okay. Like so. Like the more I play with GCC Asm and GCC and whatever, fucking hell. These extensions are so fucked. Anyways. Yeah, that one was already cleaned up. Sure. Onto CPU registers, you can manipulate them in pure C entirely, deleting some. Alright, I guess. So I don't even need. Oh, okay. Yeah, I guess it's pretty now. I could do that, yeah. So is it that? So it's telling me to do this. Okay, but now it's giving me this error. Let's see what the clanker says about it. But does it at least work? Because if it doesn't work. So fucking hell. I literally blew up this. I don't even know what the fuck. What else I need to? I can go revert back to the call these saved registers. That's one option. But I mean, it's not that hard, to be honest, to revert. But man, I would like to have this working actually. Because now, like, printfs are working. That's the thing. Um, yeah, it's basically the client just telling me to not care about it. But the fact is, I'm still getting the incorrect behavior. Like this happens. Okay, let me. This happens. I changed Kali saved registers into caller saved registers. Right, and let me give some examples. But if I do, yeah, the 69420 is a good example. Okay, so that's one example. Then this word stuff is another example. I have 69 BAM. I have word 2, that is 420 BAM. I call word 2, I call words. Like this, I only have 69 for some reason. What else can I say? Is the apply stuff even working now? I don't know. If I do apply, yeah, it's working. And then if I do 69 and then apply, well, the apply is now working. Interesting. So if I do this, then I do loop apply, and then loop apply again. Yeah, it failed. Okay. So those are also interesting scenarios. Oh wait, I need to copy that. And I'm almost wanting to revert back to the callee saves register and find an alternative. Because man, because I mean this is working because like the printfs are working now. So the printfs are working without seg faultings. But the thing is, for the printfs to work without seg faulting, everything else is broken. If I do something like that, but I then do R12 and R13, is this going to complain? No, it's not going to throw a warning. Interesting. So instead of doing this shit, I could do the opposite. So I could, at the start of my main function, I could save R13, R12 and R13 and R14. I could save all of that. Then, whenever I call a clib function, I can restore them. And that's it. So that could also fix it. Maybe. We could try that. We could try that. So let me just save this file. I don't have Git, so I cannot keep track of the changes. Let's do that. So let's try that. So let's ignore the clanker. The clanker is thinking. Let's ignore it for now. And let's go back to what we had before. So here we can do yeah, I'm being recorded for 1 hour. God. Here, what register did we had? Already forgot. Goddamn. So R12. It means that R12. So these are non-volatile. And here R12 call is saved. Okay. R12, R13. We can keep, to be honest, we can keep rux as a temp. We can keep rux as temporary. So yeah, let's do that there. And it's just to lock them up and say, okay, we are using it, so do not use this for any for loops or ifs or anything. And here we need to do something. We need to wait. If I do that and I say that I'm going to be using them, is the C compiler smart enough to fix all the issues? Maybe. Let's try that. Let's try it. So the top of stack can be R12 and this can be R11. So we can yeah, R13 actually. We can swap it from what we had previously. So R10 now becomes R12. Yeah. And then R11 becomes R13. Okay. And rux can keep being the temporary. It can be, yeah. If I do this and then I do 69 for 20, yeah, it's working. So it's something fucked with the color saved. Oh my god, 1 hour and 15 minutes and I do not fucking understand what the fuck is going on. Let me go back to the clanker. Could be the root cause. GCC's register allocation. Your call C, let me copy it. Let me copy everything and I can read it with you. Okay. So it's basically saying is a clever. Okay. Okay, I know this. It is the register are being protected. Because R10 and R11 are called saved, the GCC register allocator assumes they are instantly trashed the moment any function is called. Then you run word equals next. GCC says the function was just called, so R10 and R11 are dead. I'll use them. Oh, fuck. I see now. I see. So that's I see, I see. Yeah, so GCC is overwriting. So to use color saved registers, I need to be very careful. Um, I need to be very careful, yeah. Switch, okay, so I came to that conclusion right now, so I didn't even see what the clinker was saying, but yeah, I came to the same conclusion. We should use color saved. Um, yeah, which basically simplifies our lives a lot. We can keep that. Uh, sure. Now, this call C, what does it do? Because R12 and R13 are automatically preserved by the ABI, delete the pushes and pops, just align the stack. So yeah, we still need to align the stack. That makes sense. That makes total sense. So if our call C function just aligns the stack, so it's saying move Q, add Q, push. Basically remove this. And then I have C code, and I just pop RSP. Okay. So this is my call C function that just aligns the stack. So that one is done. A stack leak in next. If fgets its end of file, you are doing return null directly inside the call C block. This, oh fuck, am I? Probably. Yeah. In that case, I can just say, I can just say the following. Results is equal to null, and we can break from the loop. Okay. It was a nice catch. It was a nice catch. Then there is other stuff. So trashed registers inside print stack. If you read the global variable R13 inside the for loop, GC executes it during printf, but printf might temporarily use R13. Exactly. You must snapshot the globals into local C variables before. Yeah, I thought I was doing that. Actually, I wasn't even doing more because I was extracting them directly from the register. But I mean, yes, I could do this R12 and R13. Oh, and by the way, this is now fucked because, yeah. So now, let me just do this because OCD is eating. Because this R12 is T. Yeah, this is my T, so it's fine actually. And R13 is my stack pointer, so yeah, we have the that there. Okay. I already deleted it, and we can also delete it there. Okay, so in the main function, we can also delete this by just saying R13 equals stack minus 2. Okay. We can do that, and we can no longer need inline assembly. It's simpler. It's definitely simple. Like this. Sure. It was like in your force, though. You're viewing it perfectly. So look, dupe makes the stack code called segmentation address 16. Apply calls that. Oh, I need over. Yeah, I need fuck. Okay, yeah, it's correct. So let's try something. Okay, unused variable. Oh yeah. It's true. It's true. I was completely doing it. Okay, so if I do now, I don't know, this, so 69. Can I print a stack? I can now finally print the goddamn stack. Okay, okay, we have progress. So we have, this is our stack. If I now do dupe, right, we duplicate the pointer. If I do apply, we get 60. I need to do a swap first, so swap right? This is going to swap. Then I can do dupe, which is going to duplicate the stuff. Then I can do apply. Yeah, and then I can keep repeating this. So this is actually the sentence that can be repeated infinitely, I think. Yeah, without segfaulting. So it was actually a bug on my side. And now if I print a stack, as you can see, like I have a trace of 69s, and then this is the pointer I'm carrying around. Okay. Okay. So that's okay now. So yeah, we fixed the issue, not how I would intend it to be fixed, but we can delete this file. So I'm going to keep using callee saved registers, but now I reserve them, and I also have this callc macro that just aligns RSP in case that's actually needed. So I can just say 16 bytes align. Let me do this. 16 byte align RSP before calling C code. Right. And then I can just get rid of all of this shit. Something like this. And I can get a much smaller macro. I need to find like a regex stuff for VS Code. Is this? Oh, I could even make it shorter. Okay. Something like this. Because like doing this by ends, it's not that interesting, right? Okay. So I can do that. That's fine. I can even do this because that's not really needed. And it's okay. So now I have this. This it's okay because it traps the entire C code in this calc macro. These ones are going to replace all of this shit by the actual hexadecimal bytes like this, but that's for a later video. This is also going to be replaced, doesn't matter. Now here, does it make sense? Well, I could wrap all of that in calc. I guess, but it doesn't really matter, does it? Since now I'm using call is saved, yeah. I guess it's fine. I can do that, but the thing is that this is going to call encode append, also call source code. But like there is a slight inefficiency in here. But once we just emit bytes, we don't need to mem copy, and we can get rid of the clib dependency. So yeah. Then here it's fine. Here it's fine. I can even indent it properly. Okay. This one with callee saved registers. I mean, I could, just to make it like prettier, I could do this instead, right? Just to be slightly more readable. And now all the code is inside this, and I can just call this as I was doing it previously. So I can even inline everything like before. Yeah. This one is fine. This one, I guess so. It can be like that. So here I'm using call C twice. In that case, it's probably better to just call it once, like so. Yeah, it's probably better to just do that. It doesn't like something. Do I have an extra? Yeah, I have an extra stuff there. Then with that, uh, 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 so now everything should be clean, I believe. Let's reuse this example, but at the end of each stuff, I just do .s. Yeah, I can do .s. Let me do that so I can cat example.f and I can pipe it into main. Okay, so it still did core segmentation fault. Okay, so I have still some issue. If I do this and I dot s, okay, I have from 0 to 9. If I do that, okay, so it's fucking up with the nested for loops. All right, let me take a look at what is the code generated by nested for loops. Oh, it can't even define it. Huh. That's a new one. I'm gonna be honest. It cannot even compile. So it's the compilation process itself is fucked. Interesting. And I don't even know exactly where. Let's say something like this. So if I do c call c printf and I just do this, just so I know exactly where the segfault happens. If I copy all of that, so it parsed that was consumed, then that drop that there. It was in the 4. So it got into the 4, or actually it was in this one. Yeah, it was in the closing one. So it was here. So there is something fucked here. So here I'm storing it. Yeah, so this is where it needs to be patched. Or is it? Wait. So here I emit a lit. Where am I emitting the jump? Oh yeah, because I need to store that because the jump is going to be written on that address. It's okay. Let's just, by the way, put the clinker to thinking while I try to debug it. It seems fixed it, but nested for loops are broken now. So let's just copy. Oh yeah, it's slow. I do that, and I just copy these examples. Let's see what the clinker says. So here we do return. Is it, maybe it's there? Well, but well, it could be the only code path. Oh, this one is not being called. What? Ah, it's not being called. Wait a minute. Shouldn't. Oh yeah, okay. It could be somewhere here, but that doesn't make much sense, does it? Let me know exactly where in here this is fucked. If I do one, I don't know, I'm just going to fill this sheet. This should be okay. Let me say 3 and 4. And if I try to open this, So it was afterwards. What the fuck? What? Um, I'm not getting it, to be honest. So this one executed. So are you telling me this one is the one fucked? Well, let me do something. I can just get this. I can do that. I can do echo this and pipe it there. Oh, quotes depth minus minus. What the fuck are you talking about? So this is an integer. What? Oh yeah, I need to, yes, call C, by the way, call C. I think I need to wrap this still. Where was I? Here. It could be just to discard. It could be this. What the fuck? Oh, what am I doing? What the fuck is this? No, it crashes. What the fuck is going on? Why doing quotes minus minus? What? If I do it like this, does it? Nah. I've never seen it. I never seen something like this. This is like a normal integer. Wait a minute. If I do call C printf there with this and the word, yeah, it's totally fucked there. What? And if I don't do this, yep. I mean, well, to be honest, it could be somewhere else. So here, let's say I do this, but I also flush because I could not be flushing. Let me flush standard out. This could be the issue, to be honest. Nope. If I, okay, so that enters there. If I put the 6 here, is this called? Nope. Um, it could be. So the clanker is suggesting another thing. Now it's telling me to delete call C entirely. That's interesting. Okay. So the clanker is saying that this was caused because of stack alignment. Let me just prove. I haven't given it these examples. Take this example. So let me put it to thinking while I do stuff. Okay. Your calci macro dynamically shifts. Yeah, it could be actually that. But it should restore it. It should restore it. It reads a garbage pointer from jump. That makes more sense. Because that there, well, not really. I could delete call C, like I also don't like this macro, but what are you even talking about here? Yeah, I already have that tail call optimization. Like I already have that written here. I know that it's easy to implement, but that's not the point. Where was it? Tail call optimization. It's very easy to implement tail call optimization. Sure, it hallucinated here at the end, so it's not really. Like I could remove call C, but then I would need to make sure that my stack pointer is always 16 byte aligned. Because if if I'm not mistaken, if I want to use SIMD, which I have here, and like have really fast words with SIMD, I should be careful with that if I'm not mistaken. Or maybe like I could just ignore it, to be honest, and just handle it afterwards. Let me just wait and see what the clinker says for this last thing. Yeah, it keeps saying that it's a call C function. Let's try to remove it. So we basically went back to exactly what we were before with just these two extra global variables. That's interesting. So if this works, we basically just wasted like almost 2 hours. Oh, for how long have I been recording? Okay, 1 hour and 37 minutes is not that bad. But still, like 1 hour 37 minutes to come to the conclusion that I just needed two extra global variables. It's painful, I'm gonna be honest. So let's revert all of that. Where do I have call C? I have call C in more places, don't I? This one is easy to remove. Yeah, I can just remove that like so. I have call C in more places. Okay, here I just do that and that. I do this. Okay. Well, here I could say directly inline this. I don't really need this stuff. But I can keep the str equals because it's actually a really nice function. Okay. I can do that. What else? Where do I have call C? Well, I have call C in here everywhere. Let me remove it because I don't actually need it. Here I can use it. Here I can also use it. In this place. What else? I can remove all of this shit. Right, because this was just for debugging. Okay, then I have this one here, which can be removed. This one is entirely removed, and here everything else can actually be removed as well. Yeah, so now it worked. So it was the fucking call C. Like, I need to find. So basically the conclusion of this video is that once we either start playing with SIMD or maybe C interfacing, this is going to be an issue. But or maybe not, because now I can call printf and not have a crash. Let's double check. So if I do W that, and then and bam. Okay. Yeah, it's working. So it didn't crash. So yeah, so the entire solution for this video was literally just this shit. That's the only change we did. Believe it or not, we spent 1 hour, almost 2 hours, just to come to the conclusion that we just needed these two new lines to our code and it would work. Fuck. Okay. Let me test this. So I need to make sure that this also runs. So if I do that, and I do .s, okay, .s is now failing again. But is it failing because of call C or is it failing because of something else? So if I do that, oh, yeah, of course. So it's failing because this code is actually, wait, it shouldn't really fail. Oh yeah, I changed the stack size. Should I increase the stack size? I changed to 32 and this code is going to produce 100 values. Let me put 256 again. Just so I can see. Okay, .s worked now. I changed the stack size just, I don't know, just to be slightly smaller, but yeah, we can tune that later. So let me just see what the clanker said. Yeah, it keeps saying that it was the call C macro. All right, so let's just ignore the call C macro for now, and maybe try to handle the C interfacing later, because now it seems to be working, so it should be fine. Like I don't want to end this video with just two additions, like 2-line additions to fix an issue. So maybe we can quickly implement at least conditions, right? I'm not going to say like I'm going to implement ifs or whens, but at least the less than or less than equal and all of those signs. I guess we can handle them right now. So let's do something like this. Where can I put my logic stuff? I can put it here after the combinators, the stack manipulator objects. So let's I don't know, just implement less, I guess. And so less is going to basically do, so if I have a b, this is going to produce a less than b, right? Something like this. So I need to basically get the top of the stack, which is R12, and I need to do, yeah, and I need to push it back. So I don't even need to move that many things. Let's open this and it's say x86-64 reference instruction reference. I was using this one, right? Okay. If I do less, I don't even know if, yeah, okay. X86-64 less than with 2 registers. So I'm forced to use CMP followed by conditional jump, but I don't want that. I just want to push. Um, yeah, but I want to store the result. CMP to registers and store the results in a rush. Something like this. Perform the comparison between arg1 and arg2. The comparison is performed by assigned subtraction of arg2 and arg1, the results of which can be called temp. Temp is discarded. The flag register is updated and can be used in a conditional jump, like jump if equal. Yeah, but I want to like, oh, I have set to store the result of comparison. You typically follow it with a conditional jump or use the set CC. Okay, so there are two things we need to do. So there is a CMP somewhere here. Yeah, so we have here a CMP, and here we should, yeah, it has immediate, but I don't care about that, so we care about this one, I guess. So CMP memory and register. Okay, so we can say CMP and we can compare. So what is the order? The other stuff already. Okay, I closed it. Okay, we can swap it if it's needed. But I presume it is something like this. I assume it is. So we have R12 compared with R13, and then there is the other stuff, the set CC. Okay, set byte on condition. Is it okay? That's the only thing we can do. Set byte if above. Okay, so can I go back to the, yeah, it is this one. This one was cool. If AX is less than BX, so AX is my, okay, so I want it the other way around. Yeah, I want it like this, because this is the second value. Yeah, something like this. So this is my AX and this is my BX. Okay, if AX is less than BX, ZF and CF set to 0 and 1, and here let's search for it. CF is 1 and ZF is 0, so there is nothing like that. What the fuck? Isn't there a CF? Okay, CF, but this one is 1. There is no such, okay, so I need to swap them again, right? AX is greater than BX and just pretend. So if the second, so basically this is doing, if S is greater than T, right? Then these two will be 0. But how do I even copy that into set byte if above? So I want basically this one, right? If condition, then destination is equal to 1, else destination is equal to 0. So that's the operation we are doing. So if this is true, which means S is greater than T, let's just, in that case just swap this, it's easier. We can just then call theta, I guess, with the R13. So we are going to overwrite R13, which is what we want. So if I do this, actually R12, sorry, R12 is our new top of the stack. So we are basically saying if true, if that is true, t is equal to 1, otherwise t is equal to 0. So that's basically the thing. I suppose it's something like this, I suppose, but I'm not really sure. Let's try it, let's try it. I just need to do this boilerplate stuff. And then I can have another stuff here. So this is greater. And here I can say this, yeah. And here I can say greater. And here I can swap that for greater. Right, something like this. So if now, okay, operand size meets, okay, fuck. Why? In 64-bit mode, cannot be encoded to access the following byte registers if a rex prefix is used. Fuck. Okay, so let's ask a clanker to help us. I think this one it can be useful. Okay. I can say that. I just want to compare both and put the result in R12. I think it's R12, right? Yeah. Let's see what it says. Okay. But this only sets the low bytes. This is not correct, because if I zero this out, then this comparison is going to be fucked, right? But I can zero it out afterwards. So I can, yeah, I can say that. I can XOR it, R12 with R12. That's an option. So I'm basically saying t is equal to 0. Basically clean, right? Because this one is only going to set the low byte. And here it used this B stuff. Maybe that's what we need to do. Okay, it didn't complain. So now, now if I do something like 42 and 69, right? We have 42 and 69 on the stack. If I do greater than, what am I going to have? 0, because 42 is not greater than 69. Good, that's good. And now, oh, but I kept, fuck, I kept 42. This one needs to be consumed. I forgot about that. So that one needs to be consumed. And to be consumed, I can just subtract. Yeah, I can literally just subtract. So I can do comparison. I can just say basically S minus s is equal to s, or actually I can say it. Okay, so we're going to pop that value and then that. Okay, so if now I say 4269 greater, I have 0 without, and both values were consumed. But if I do 6942 greater, I still get 0. Why? Huh. So if I do that, working. Let's see. You're using R12 after the comparison. So set it right into the low byte, then you clear it with XOR. What? If you want a signed comparison, use set G. What the fuck is set G? Set byte if greater. Oh, okay. Have the same opcode and test for the same condition. ZF equals 0 and ZF equals OF. Okay. Alternate method was okay, but if I do then set G, it shouldn't make a difference, right? But I don't understand what exactly it is trying to do, because compare that sets flags for, yeah, that's what I want. We pop it. It shouldn't really matter, should it? So if I do 6942 greater, it still prints 0. And if I don't do this shit, it printed 1. So it was the XOR that was fucking it up? Or is it? Because now if I do 4269 greater and I print, yeah, it keeps printing ones. So there is something really strange. Okay. Give me assembly code that compares, that does the following. If R13 is greater than R12, then R12, yeah, R12 equals 1, else R13, R12 equals 0. Maybe if I do this, it's going to be slightly more capable. Move GT. Well, that's C set. What the fuck is C set? There is, okay, so there is another stuff with C set? No. What the fuck is C set? Oh, but this is for ARM. Okay. x86-64. Okay, I forgot to mention. Yeah, okay, so I need compare Q. Sure, that's one thing I need, because I'm comparing quad words. That makes sense. Then set G, all equals 1 if R13. Okay, what is the register that is inside Rux? What are the registers inside Rux? Like in 16-bit mode, and yeah, this one. AL is the 8 bits. Yeah, it used it. So yeah, Rux is our temporary register, so AL is also a temporary register for us. So it is telling me to do, I still need to do that. Okay, so set G al for some reason. Okay, so it's basically saying this is my temp, like just the 8 bits of temp, like this. But then it's telling me to do the following: moves BQ. Zero extends. Okay. Zero extends that, I guess so. And I say T is equal to temp8 0 extended. It could be, but I don't think that's the actual issue that we're facing. But we could try it. Where is it? It's here. Um, oh, here. I need that. And I need that. Okay. So 40 to like 1 to greater. 1 is not greater than 2, right? 2, 1 greater. Oh, sorry, yeah. Fuck. 1 to greater. I print incorrect words. 2, 1 greater. Yeah. So this shit, like, compares R12 with 8 bytes of at address. Yeah, but that's what I want. Doesn't matter. It doesn't have. Wait, so you're telling me that I need for that to be a register? Um, compare string. This one actually is going to be quite useful for forever to have a primitive word that's fast. But yeah, so here we can have a register and memory, but can we have memory? Yeah, we can have memory and the register. Let's ask the super clanker. So I need to implement the greater words. Wait, no, like the conditions being flags inside the register is quite a very I would say bad design decision from the for the ISA, I would say, to be honest, because sometimes you just want to extract the value, and here you'll have to like do a bunch of shit just to extract it. But um it is basically saying that subq is fucking up the I see. So do I need to subq after? Yeah, do you see why? Like, let me just test it first before I run it. And then 2, 1 greater, and then if I do that, yeah, it's working. Okay. So this is why I was saying, like, it's a very bad design decision, because if you're going to use flags to signify the value returned by the comparison, then we have this issue, because if you use subq here, fuck, where is it? If you use subq there, this one is going to overwrite the flag and it's going to be lost. If you use it there, it's going to be fine. I think that's what the Clanker was saying. Yeah, exactly. Yeah, I can move the subq afterwards. Let me check. Is there a more efficient of implementing this word? Right. Okay. Like it's so fucked. I need to get rid of the as soon as possible. Like this implementation. I need to implement like a very simple but very optimized kernel of words, and then start implementing everything else as part of the standard lib of the language, right? Because this kind of shit, like, they pissed me off. Like, this shit is overwriting the flag, and then this shit was writing that instead of that. Goddamn. Right, let me just see if there is a slightly better way of implementing this. If not, I guess that's everything. But, like, by the way, we can already implement other stuff, right? It was set cc, yeah, set cc. This one, yeah. We can implement greater than or equal, less than, equal. Yeah, we can do all of that stuff, to be honest. Okay. Development method is actually to optimal. You write sure in SQLite almost exact same code. So it okay. So the C compiler is going to emit almost the same code. Okay. In 64-bit general purpose register as an address 8-bit subregister. So it's telling me because you don't need the old value. Zero extended in place. Okay. So it's telling me that I can do the following. I can just do R12B here. Then I can zero extend it with itself, but just the bottom bytes. Right. So here is going to be T, but then yeah, zero extended. And I don't need the rack stuff. Yeah, and that's it. So this is the optimal implementation. Okay, let's just test it. Make sure. So 1 is greater than 2 is false. 2 is greater than 1 is true. Okay, so I can finish that. Okay, so let's add those examples here. Say 1, 2 greater, 2, 1 greater, and we have .s. What else? We can implement everything else right now because everything else is super easy. It's just a change in this thing. So less in this case is going to be L. So that's literally the only thing we need to change. We can implement less or equal. You can say less EQ or something. Yeah. And here is LE, I suppose. And you can also implement greater or equal. Greater EQ. and in this case it's going to be GE, and I guess we need equal, right? And the equal, I suppose it is just set E. I'm going to assume that. Okay, but we can see, yeah, set E. So that does exist. Okay. So that's like that. So let's implement all of that and we can end the episode here. So we're going to have this. And then we are going to have this, but for EQ. Right, then we are going to have this for less and this for less EQ, and this should be everything. I can give it better names afterwards, it's fine, don't OCD too much. Yeah, so here we need all of that sheet, so there's a lot of boilerplate, but once it's done it's okay, we don't need to touch it anymore. So equal greater or equal, then we need less or equal, and we need less, and we need to implement all of it. Okay, so that's fuck. Okay, I need underscore equal. This is going to be just a simple equal because like we don't have assignments because we are not going to have variables, so it's okay. Okay, let's say equal. Then here I can copy paste this to have the greater or equal, and that's just that. Here I can fuck and say greater EQ, and then I can copy these two to just have the less. So I can swap this for less. This is less, less or equal, and this is less. Fuck. Yes. Okay. So we should now have all the logical things, operator words, actually defined. So let's test it. 1 is equal to 2. It's false, but 1 equal is true. So let me try to test it in a different way. So 1 equal, I can print and then drop. Yeah. Okay, so we have true. Then 0 1 equal is false. Okay. Then for the greater we can do 1 greater drop, we get 0. 1 is greater than 0 drop, it's true. But if we have greater or equal, so 1 is greater or equal, we get true. 1 0 greater or equal, we should also get true. But if we have 0 1 greater or equal, we should get false. We have false. Cool. Now for the less, 1 less than this, it's false. That's correct. 1 0 less should give us false as well, but 0 1 less should give us true. Okay. Then finally this one, so 1 1 less or equal, it's true. 0 is less or equal than 1, it should be true. It's correct. And 1 is less or equal than 0, it should be false. It's correct. Okay. So that's basically everything. Let me just put in example so I can remember all of it. So here I can just remove this stuff, but everything else is perfectly okay. So these are all very good examples. And here I can do the same stuff. Oh, this is already covered there, so yeah. So this is the logical word condition, like logical condition words. All right, so yeah, it seems to be working pretty well. And with this we can have while loops if they are needed. I don't think I'm going to implement them for now because they may not be even needed, to be honest. But yeah, the only last thing I want to check is that when I did this, I got a segmentation fault. Why is that? So is it because so it could not find and it just seg faulted for some reason? Are you seg faulting because of this? No. So there is something else. There is something else. Are you seg faulting? Where exactly are you seg faulting? So if I do that followed by that a new line. So if I try actually say this, if I try to print I and then this, yeah, this one, LD, sure. It didn't even get there. Huh. Oh, because vocabulary count is 0. Oh yeah, because this is fuck, this needs to be, yeah, okay, okay. Because it was underflowing. It was underflowing and then it got all the way up to 2 to the power 64 and then it was fucking it up. Okay, but now it should be, yeah, it should be fine. Okay. Okay. So any word that I type that does not exist, now it doesn't seg faults. But if I type a word that does exist, it is parsed correctly. Okay, cool. So I think we fixed all the bugs that we had at the beginning of the video. We fixed the seg faults. We fixed this shit that we found right now. We added this debug at the ability to debug the stack following the REPL. We fixed all of the other issues with this shit. We use now Rax as a temp because we can use it. Rax can be discarded easily. Then we kept R12 and R13 for the top and second element pointer. We just swapped them both just to be clear about this. We implemented conditions and we basically cover all of the conditions. I don't think there is any other one that we can add, but if there is, like, it's easy to add it. And yeah, I think that's it. Like, we are ready to implement ifs and when using quotes in the next video. Yeah. And after that, we should implement arrays as well. And I think after that, the entire language is more or less defined, right? After that, it's just a matter of optimizing stuff. Maybe we can add green threads, but yeah, I need to think about it. So I know this was quite a boring video. Sorry for that. I spent nearly 1 hour 45 minutes around an issue that was completely like fucked, but yeah. Thank you for watching and I'll see you in the next one.